I said in an earlier video that you can't use synthetic division unless your divisor is a binomial whose x coefficient is 1 and whose x exponent is 1. So it has to be, in general, in the form x minus k. Well, it's kind of true. But suppose we're given a number like x squared plus 4, or a number like 3x plus 4. Can we ever divide by these kinds of numbers using synthetic division? Kinda no, kinda yes. See, here's the thing. If we want to divide by these kinds of binomials using synthetic division, we're going to have to rewrite them in this form. But that's not like it's something that can't be done. We can do that. Let's start with this one, 3x plus 4. Suppose I'm asked to divide the number 3x cubed plus x squared minus 64x minus 80 by this number. And I specifically chose a polynomial where it would divide evenly because I like to have a remainder of 0, and I'm sure you do too. So suppose I wanted to do that. Well, because this is a 3x here, I can't just go ahead and make this negative 4 and use synthetic division just like old times. What I'm going to have to do is rewrite this. So here's what I can do. I can factor 3 out and get 3 times x plus 4 over 3. And now I can make my k equal to negative 4/3, and then I can use synthetic division. So we've got 3 is our first coefficient, 1, negative 64, negative 80, and then our k is negative 4/3. So this will be a little trickier, as you can imagine, but it's doable. Watch. Bring down the 3. Negative 4/3 times 3 is going to be negative 4. 1 times negative, or 1 minus 4 is going to be negative 3. Negative 4/3 times negative 3 is going to be positive 4. 64 minus, or negative 64 plus 4 is going to be negative 60. Times negative 4/3 is going to be positive 80. Negative 80 plus 80 is 0, and it worked. See, we got 3x squared minus 3x minus 60 is our answer. And this tells us that x plus 4 over 3 times 3x squared minus 3x minus 60 is a way to rewrite this polynomial. But if we don't want to use this, if we don't want to leave this 4/3 in here, no problem. See, look, 3 is factored into all of these, and we can rewrite that as 3 times x squared minus 3x, minus x minus 20, and then this 3 is free to be multiplied into this binomial to give us 3x plus 4. So our final answer would be 3x plus 4 times x squared minus x minus 20. So it is possible to use synthetic division in a situation like this. It may or may not be helpful. You might think it's faster to use long division this way, or you might think it's still faster to use synthetic division, whichever you prefer. Now, this x squared plus 4 gets even trickier, but we can still do it. See, how can we get this into a form x minus k? Well, really, we can't. We can't factor anything out of it because we don't know what x is. But here's what we can do. We can factor this into 2 terms, x plus 2i and x minus 2i. Alright, now why did we just do that? Well, now it's in the form x minus k, isn't it? We've got 2 of these in the form x minus k, so we've got, in this case, our k is 2i, in this case, our k is negative 2i. And if we divide by these one at a time, then altogether we'll have divided by this. Now watch, it'll get a little complicated at first, but then it'll simplify out beautifully. Now let's say we want to divide this polynomial 3x to the 4th minus 5x to the 3rd plus 16x squared minus 20x plus 16 by x squared plus 4. Well, what we can do is we can rewrite this and divide it first by x minus 2i and then divide it by x plus 2i. And if we're going to do that, we can actually use synthetic division because our k is going to be 2i and negative 2i. So let's just take these coefficients, 3, so I'm going to move it over here, 3, negative 5, 16, negative 20, and 16. Letter k first equal 2i, so we're going to be dividing by x minus 2i first. Alright, let's boogie. Bring down the 3. 3 times 2i is 6i. And here's our first hitch we run into. This 3 isn't anything, by the way. Okay, negative 5 plus 6i is what? Well, it's negative 5 plus 6i. It's a complex number, and that's going to be one of our coefficients. Now, 2i times negative 5 plus 6i is going to be negative 10i plus, let's see, what's 2i times 6i? 2i times 6i is going to be 12i squared, which is 12 times negative 1, or negative 12. So negative 10i minus 12. So now we've got 16 times negative 10i minus 12. And that gives, 16 plus negative 10i minus 12. 16 doesn't interact with this negative 10i, so that's just going to be negative 10i. And then 16 minus 12 is 4, so negative 10i plus 4. This really should be written as 4 minus 10i because of the format of complex numbers, but that's alright. Okay, 2i times negative 10i plus 4. Well, 2i times negative 10i is going to be negative 20i squared, which is positive 20. So 20, and then 2i times 4. That's going to give us 20 plus 8i. Okay, negative 20 plus 20 plus 8i, well, that's just going to be 8i. And then 2i times 8i is going to be 16i squared, or negative 16. 16 minus 16 is 0. So we went through all that, and we did end up with a remainder of 0. And our new polynomial is 3x squared plus negative 5 plus 6ix. Or, sorry, 3x cubed plus negative 5 plus 6ix squared plus negative 10i plus 4x plus 8i. So it's a pretty complicated polynomial, but we're halfway there. Now we can divide this polynomial by x plus 2i using synthetic division. And this is the fun part, because our first coefficient is 3, our second coefficient is negative 5 plus 6i, our third coefficient is negative, well, we'll put it as 4 minus 10i, now it's in correct form. Our fourth coefficient is 8i. And then the 0 is just a remainder, so that's not a coefficient. Now we've got negative 2i as our k. Alright, let's see what happens. This will be fun. Bring down the 3. Negative 2i plus 3 is negative 6i. Oh, watch what happens. This negative 6i cancels with that, and we get negative 5. Negative 2i times negative 5 is going to be 10i. And this 10i cancels with that negative 10i, leaving us with 4. This 2i, negative 2i times 4 is negative 8i. Add these together and we get 0. So we have a remainder of 0, and suddenly all of our coefficients are real again. And we've got 3x squared minus 5x plus 4. So now we know that 3x squared minus 5x plus 4 times x squared plus 4 is going to be equal to this polynomial up here that we started with. So we can actually divide by things like 3x plus 4 or x squared plus 4 using synthetic division. It's just a little more complicated, but, you know, more complicated means more fun, right? 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 Anybody?